Everybody listen to me? Yeah? Perfect. So, I'm Rascagne, and I represent you a work I performed at the beginning of the year. But before starting, I've got a surprise for the guy from Backstage, because they made a really nice work. They come from really far, so make a big travel to come here. And at the beginning, Eric suggested to me to make a striptease, but I'm not sure it's a good thing for this guy. So I decided to make something else for the team. So everybody knows the logo of the guy from Malwest Must Die. I'm ready. So here's a quick description. So here's a schedule of my presentation. First, I will speak about my website and my company really quickly. And after, I will speak about the work I made concerning a specific group of attackers I will mention after. So, my name is Rascagne. I work for Trust Consulting, a company located in Luxembourg, and more precisely for malware.lu. Company specialized in malware analysis, in incident response, this kind of stuff. Here's some number about our website. In fact, we have a website that allow you to download samples of malware to make your own analysis or have your own opinion of specific case and this kind of things. So, before starting, I would like to speak about the attribution on my title. You've got APT1. When I make the analysis, I thought that was this group behind this server, but after speaking with some different company that make some research about this group, in fact it's not a good attribution, it's another group, but it's not the main purpose of the presentation, so it's not a big deal. So, I start to work based on the document created by Mandiant about APT1, a group of Chinese people. I think everybody heard about this report, and on it they spoke about a specific remote administration tool called Poison Ivy, and I start everything thanks to this information. I will speak later about Poison Ivy and what it is exactly. So the first thing I do is to create a scanner to detect Poison Ivy server. In fact, I send specific request to a server on a specific port, and if it's a Poison Ivy daemon, I've got a specific answer. So it's really easy to create this kind of scanner. Here it's the Python script to make this kind of things. The second thing to do once you've got the scanner is for me, it was to limit the scope of IP to analyze, because I cannot scan world's internet. So I limited the IP range to Hong Kong IP, and I limited the number of ports to these 4 ports. The first one is the default port of Poison Ivy daemon, and the 3 others are the ports usually allow in company to go outside to browse or make HTTP, HTTPS, this kind of thing. So I voluntarily limit the scope to be more efficient. So something really nice, or not, it depends. Here is the main IP range when I found Poison Ivy daemon running. Something fun fact, it was the IP. Sometimes I got a Poison Ivy on the IP that finished by .100, 100.101, 102, 103, 105. So I don't think it's by chance, but the guys buy a set of IP and I install a poison ivy daemon on each of it. So you've got the main poster I found. And something really complicated for me is that the guy stopped the poison ivy daemon, stopped the server completely when they don't use it. So if I scan at, for example, 8 EM, the daemon is up. If I scan at 8 PM, the daemon is down. So thanks to this information, I was able to create a graph of the working hour of the guy. So usually they always start between 1 and 2 EM and finish the day around 10 PM, depends of the day. They work every day except on Sunday. So it's a Luxembourgish time zone, the same time zone in French. So you can easily check on the map where is this country. So to work, I have to wake up at 1 EM. It was really hard. And to not wake up for nothing, I decided to wake up when the first machine was up. So I have to make a clock to detect if the machine was up, and if the machine was up, to wake up me. So I will show you my clock. So it's my own Raspberry Pi board to ping the CC. Python script with network check. As you can imagine, my wife really appreciates my clock at 1 PM. And my children too. So, come back to the main topic. What is poison ivy? I think everybody of you already heard or maybe played with poison ivy. It's a remote administration tool available on the internet, and it's not maintained since 5 years, something like that. But you can always download it here, and you can do everything. You can share the file, find specific data on the file system, manage the registry, etc. You can do everything. So, Andrzej found a vulnerability on poison ivy a few years ago, I don't remember when, and a Metasploit module was available on Metasploit. And first I tried to use this one, but I don't exactly know why it didn't work. So I decided to modify the exploit provided by Metasploit, because in fact we have two modes. When you configure poison ivy, you set a password, and the password is used to encrypt the communication between the client and the server. So on Metasploit, the first thing was to try the default password, admin, and in this case the attackers didn't use admin. And second option is to make some brute force, but it doesn't work too. So I decided to understand the exploit and to modify the exploit to be able to set the password manually on the module. So the first thing was to find the password before setting it. Poison ivy uses Camellia encryption, so it's right on the official website, so nothing mysterious. And Poison ivy supports a kind of ecosystem. You can send data and you reply with you with the data encrypted. So thanks to these tricks, I was able to send a lot of null byte or something. I got the encrypted starting pattern, and I can make some brute force things to find the password. To do that, I create a module to John the Ripper because John the Ripper doesn't support Camellia natively, so I had to add these things. And I decided to use John the Ripper to brute force the password. And the password used for the communication is this one. So I make a lot of time to create everything for a 6-character password. I cannot guess before having it. So I modify the Poison Ivy exploit to be able to set the PSW password. And thanks to this modification, I was able to use the exploit and have the access on the machine managed by the attackers. It's not correct. So something really nice when I exploit the first machine, I tried to hack the IP x.x.x, for example, and I always use a reverse shell on Metasploit, and I had a reply from y.y.y.y. I tried to go on the machine, and another one has replied to me. So in fact, in this case, it means it's a proxy server. I go on the proxy server, the proxy route me on the real backend server, and the backend server replied to me directly through Metasploit. And another thing interesting is the vendor ID of the eternal card was the MAC address of VMware server, because always start with the same data. So here you've got the MAC address of the machine. So the next step was I got an access on this specific machine. I was able to draw a schema of how these attackers work. You got infected machine at the bottom, internet. Got the proxy server automatically forward to the real Poison Ivy server, and the attackers here never connected directly to the Poison Ivy server through RDP, for example, but they use VMware tools to be able to connect through the hypervisor. So in this case, I don't have any logs on the Windows system about the attackers because they don't really use the system but use the hypervisor to go on the system. So it was a mess, and I never had the IP of the final attackers in my case. So here it's the list of the IP I found with an IP server, and I make some filter, etc. So I found 300 server managed by this group with the same configuration. Here you've got the logging prompt of the Windows server, and it's right in Chinese. Here, during the working hour, I make some screenshot of the system used by the attackers. Here you've got the Poison Ivy interfaces with the ID, the IP of the machine, user ID, what kind of machine, the system, the username, etc. Every information about the infected machine. And here you've got an cmd.exe executed on infected machine during my investigation. So now I decided to make two things. The first thing was to find additional tools used by the attackers, because maybe they don't only use this rat, they use other one. They have post-exploitation tools to dump memory, password in memory, or anything, I don't know. And the second step, the step that takes the most time, is to identify victims and warn every victim. So first I find an additional remote administration tool on the system. It's called Terminator. I don't choose the name, it's the name of the binary I found on the system. And typically victims were private company, public company, political institution, or government, activist, association, reporter, different kind of profile. Generally, attackers look for media document or office document or JPEG or this kind of things. So, just for information, the number of victims is around 40 different kind of people. I think I won 80 or 90%, but sometimes I never found who is really the targeted system. For example, for reporters, I've got a machine where the username was reporter1. So it's complicated to find the real name of reporter1. And yeah. So what about Terminator? I will show you. Before, the client part, the malware part of Terminator was already described by Trend Micro and named Rascagne. And as I was on the server, I was able to download the server part, the part used by the attackers to manage an infected machine. Something fun is when you launch the administrative part of the RAT, you've got a password. I don't know exactly why they had a password, but it was not really clever. You've got the algorithm to check the password entered. It's a complicated way, but the other way is simply to switch the condition, and every password works except the good one. So it's for dummies, and if you would like to understand. And I make a tool to brute force and find the real password used by the attackers, and you got it. And in fact, I think it's after some search on Google, is the username of the developers of the RAT. So it's useful. So I will show you how is the tool. So here you've got the application used by the attackers. Really, every day when they wake up, they started this interface. Sorry. And I've got the malware here. So yeah, make something fun. Here, you can see that a new machine is infected. Here, you've got the name, IP, etc., etc. You can double click on it, and the system of this malware is really common for this kind of things. The malware doesn't include the feature. It only waits for having a DLL or this kind of things. So if you analyze the malware alone, it simply waits to have something to execute. So in this case, you've got a plug thing, and you can select a feature. In my case, I select process plugin, and I upload the plugin to the infected machine. So I simply send a library to the infected machine to support process management. And when I go back to process, I got every process of my infected machine here. And you can do the same thing for a lot of different things. You can manage file, have a shell. I'm able to list file and have a shell, basically. I can make some screenshots of the users, edit the registry, manage the service, have information about the system, the level of patch, etc., etc. A keylogger to dump password, and I don't remember, but you have all this functionality, and it's really easy to use for attackers. So now I decided to make the same thing. I create a script to detect a Terminator daemon running on the same range of IP. So something really easy to detect if you have a poison ivy infection on your network. The client part, the infected machine, send HTML to the server. The bad way. Normally you get you download HTML code when you browse on the internet, and in this case it's the opposite. The client sends HTML data to the server. So if you have this kind of pattern from your network to the internet, bad news. And I make the same thing. I send this data and I wait the reply of the server, and if I get something correct, I'm able to say it's a Terminator daemon on this IP or this port. And as I had the server part of the malware, I was able to check if I don't find any vulnerability on it. And suddenly I found, sadly for the attackers, I found a vulnerability on the server part of Terminator. So I decided to name the vulnerability Judgment Day, because they decided to call the malware Terminator. And I was able to have access on another set of machine managed by this the same group of hackers. So, to conclude, during my work, I found more than 300 servers used by this group. Each server was dedicated for a specific victims. So, when you have access on a specific machine, you only have one targeted company or government. And when this company detects the attackers, the server will be used for another victims, and etc. So it's a way they work. They use proxy to hide their real machine. So one server per target. They use a custom malware. The first one is really common malware available on the internet, and the second one is more complex. And it's fun because I continue to see what kind of malware this group use. So they start with Poison Ivy. They switch to Terminator. Thanks to my report, they switch to GRAT, rat in Java. And after they switch to Bozok, B-O-Z-O-K. And currently they are moving from Bozok to another one. I don't have the name yet, but each 3 or 6 months, depends, he switch to malware to another one. They seem to be good organized, and something really nice. I think they have a level 1, level 2, and level 3, because the guy tried to execute a command and make an error, and tried to execute exactly the same thing and 3 times. And after 10 minutes, I think a new guy arrived and makes the command correctly. I think they escalate the ticket. I cannot do that. Why? So they have this kind of thing, or maybe he reads the documentation. My work was nominated in Pony Award this year, and the second year I was nominated. But in front of me I've got Snowden, so no luck. And if you have questions, you can ask me, but no question about the law, because I'm not a lawyer with an error. So other people can reply to you concerning the law, but not me. Just for information, if you would like the source code of the exploit or scanner or everything is on a report available on malware.l. So you can download everything if you wish.
Thank you. There's a question on Twitter about legal issues.
Yeah, but I cannot answer. I don't know.
Okay. Any views, comments, questions?
Hi, Paul. You said that these are not APT1 group. This is another group.
Yeah.
And judging from the working hours and their organization, would you say that they are in a similar country than the APT1 group or another one?
It looks like the same. But after some guys here work during the night, so and you are not Chinese. During my analysis, something sad for me, I don't have a holiday day of specific country during my work. So I cannot confirm that, for example, they didn't work during this day because it's a vacation day in this country or this country. So I don't have this information to correlate the country, for example. Yeah. The only day they don't work is Sunday. The only one is Sunday.
Any information regarding the binaries used to infect the victims? Whether
Yeah,
default
I
or maybe
don't-
encrypted versions,
Yeah.
encrypted
I
versions?
don't have the information. I got the binary, the real malware, in fact, the poison ivy binary, but I don't know how they, if it's spear phishing campaign or I don't have the
No,
information.
I mean the binary itself was a default one generated by the poison ivy
Yeah,
builder, or it was custom built afterwards?
no,
Maybe
no,
they
it's
tried to encrypt
poison
it.
ivy binary generated by poison ivy application.
Okay.
Yeah, it's yeah.
The
No
default one.
customization, no specific packer, no nothing.
Last question? Everybody's shy.
So they handle their victims just like in a FIFO, first in, first out, in a pool.
No, they infect a first group or company or I don't know, and I saw a lot of infected machine. But once the company detects this infection and, for example, blocks the IP of the proxy server or these kind of things, they automatically. I don't know. I don't know exactly how, if there are a second way on some specific malware to be able to switch easily. I detect the first way, the target blocks the first way, so I got a second one to be able to add, to put a new sample, a new malware, or this kind of thing. I don't exactly know how they do to switch from a specific malware to another one, or if they send a new spear phishing campaign, I don't know.
Last warning. Jessa?
This is just to answer one of the questions. I was one of the people who did analysis on the binary of Terminator. So we wrote a paper on that, and we found it came from spear phishing emails, and it targeted a news company. So it makes sense that one of the victims is a reporter.
Yeah, concerning the infection part, I don't have the information. And for example, they don't compile the binary or create the binary on this server. Maybe they make it on their laptop or these kind of things, but they don't create things on the server. The server is only used for operation. For example, the guy work around 10 hours per day, but never go on Google or etc. They only make the job. The machine is dedicated to these things and do nothing else on the server.
Hello, Paul. Is there any possibility that the servers can access the client through the proxy? It's very important because of to mitigate the blocking. Is it gonna be the real IP addresses, or they can proxying also to another, like a different layer, for example?
Sorry, I didn't understand.
Okay. There is a server, there is a RAT, not direct connections, but can be proxied to something and then go to the client. Did you find the case like that or not?
No, I didn't find.
Okay.
Yeah, thank you.
Thank you.